So maybe while we're waiting for more people to join us, if you guys want to introduce yourself, tell me a bit more about yourself and what kind of background you guys have in blockchain in general or distributed systems programming. So I kind of know my audience. Or we can just wait for people to join us.
Can you hear me?
I cannot hear anyone. Let's see, I'm not muted and
Does this work? Can you hear Megan?
actually maybe I should try calling in from the phone and that might help.
Megan, I can hear you. So she has something. Naba has something to do. Her speaking.
Oh, Nadia can't hear, but you can hear me.
I can hear you.
Okay, I was just gonna introduce myself. I'm Megan Reinhardt. I live in New York, and I'm a senior product manager with AT&T. So I've been in product for about 5 years, and I do like a course in Ruby on Rails, but I'm pretty much a junior developer, more of a business lead. So I am, just here to learn about Hyperledger, Hyperledger, and
there are 5 participants in the meeting.
Hey guys, so I just joined like the call. I'm not using my computer audio because I don't think it's working properly. Did anyone say anything that I missed? No. Okay, so it's 5 minutes past 10. I think we should just get started. We only have 3 people or 4 people in the call. I don't know if more people are going to join. Are you guys all remote or are you guys in a room so you guys know if there are more people who are going to come join us? Yes, I guess I will get started. Welcome everyone. My name is Nava, and in the next 1 hour we are going to be doing a very crash course into Hyperledger Fabric. So a bit about myself. I'm an engineer by training, and I work at a bank in the cybersecurity space. I've been in the blockchain industry for like over a year now, and I also teach blockchain and Hyperledger Fabric specifically at the Blockchain Hub out of York University here in Toronto. And here I am today. I'm going to be in the next 1 hour. Actually, let me go to the agenda then. So yeah, in the next 1 hour, I'm going to try to pack in a lot of things. I think blockchain and Hyperledger Fabric in itself, it's a huge topic. So some of you guys might find it very, like, you might think I like rushed over a lot of things. If that is the case, please tell me to like deep dive into a concept which was not clear or which I did not cover in detail, because there's a lot of materials we need to cover. So we will do a quick introduction to blockchain. Then we are going to do like a little deep dive into Hyperledger Fabric. It's going to be followed by the functionalities of Hyperledger Fabric. We're going to talk about its module and its architecture. And then we're going to look at what identity, membership, nodes, all of that in Ledger, all of these mean in the Hyperledger Fabric world. I will also describe the real world use case of Hyperledger Fabric. In fact, it's going to be a small video that we're going to watch, not very long. And I was going to do a hands-on tutorial where we would build an end-to-end Hyperledger Fabric application using the Node.js SDK. But I'm having issues with my laptop, so we won't be like, internet is really slow, and I need to connect to Docker to pull images. So that will not really work. But I will show you guys an application I have that I was going to demo and run through with you guys. And we will be looking at the chain code I wrote, and we'll also look at the Node.js application that could have been used to interact with the blockchain network once we deployed it. And at the end, if there are any questions from you guys, then I can answer that, or you guys can also just like send me a message. So yeah, I guess we're now gonna go into the introduction. So I'm sure like everyone here in the audience has heard of Bitcoin or they know of it, because like from a lot of conversations that I've had, that is one reason many people got into blockchain in the first place. But some people tend to confuse blockchain with Bitcoin, and so like we're going to start this hour webinar by asking ourselves, what is blockchain, how it's different from Bitcoin, and then we're going to answer the question of what is Hyperledger Fabric. Let me see if there are any questions. Yeah, sorry. Yeah, I guess there are no questions. Yeah, what is blockchain? There's a book by Dan and Alex Tapscott in which it's called Blockchain Revolution, and they describe blockchain as the new Web 2.0. Some have even called it the next internet. So it's a very big comparison, I feel, to call it compared to being the next internet, which really brings us to the question: what is it? What is blockchain? And in the simplest words, it's a network of nodes. There is really nothing novel about the technology itself. It's built upon existing concepts of public key cryptography and P2P networks. And it's the way the two concepts have been combined that makes blockchain so novel. But really, at the end of the day, it's just a distributed database which immutably records all the transactions that are taking place in the network. And it's immutable because of public key cryptography that it uses, and the guarantee that it provides that a transaction cannot be modified, therefore making blockchain an append-only system. So now it brings us to the next question: how is it different from Bitcoin? Bitcoin is a cryptocurrency which was built on top of blockchain. It's like you guys, I would think, like, have used Google Map or a similar application before. Google Maps needs internet to retrieve directions and show it to others. It needs internet to trace addresses, etc. So internet is the blockchain which enables Google Maps. If the app Google Maps disappears, internet will not cease to exist. However, if internet disappears, Google Maps will pretty much be useless. You cannot even access Google Maps. And this is the same relationship between Bitcoin and blockchain. You can have blockchain, the underlying technology behind Bitcoin, without having Bitcoin. However, you cannot have Bitcoin without blockchain. So we know what blockchain is. It was a very high-level introduction to blockchain. We know how it's different from Bitcoin, which really made it so popular. Now we're going to answer our next question: what is Hyperledger Fabric? So Hyperledger Fabric is a blockchain implementation, blockchain framework implementation. It was initially contributed by Digital Asset and IBM. Hyperledger Fabric, with its modular architecture and plug-and-play capability, serves as a foundation for developing permissioned or private blockchain applications. So ready to put it in that, is someone saying something? No, okay. So to put it another way, Hyperledger Fabric is a framework to create enterprise applications with network security, scalability, confidentiality, and performance really in a modular blockchain architecture. So now we're going to talk about Hyperledger Fabric functionality. The screenshot up there is taken from Hyperledger Fabric's official website, and you can take a minute to read it. They're listing the key features of the platform. It says that there are channels for sharing confidential information, which is what makes it private. Blockchain, there's order and service to deliver transactions consistently to peers in the network. Endorsement policies for transactions that uses CloudDB as the underlying database for world state support. It has its own membership service provider. So like for the person who's like understanding Hyperledger Fabric for the first time, it all seems like a mouthful. And so I guess in the next section, I'm going to break down what these functionalities are and what they really mean. So one of the main features of Hyperledger Fabric is identity management. It provides a membership identity service that manages user IDs and authenticates all participants in the blockchain network. This is what it enables you to have a private blockchain feature, which is a huge differentiator from other blockchains like Ethereum, where everything is public and everything is open. Furthermore, Hyperledger Fabric allows enforcement of access control on specific network operations. So as an example, you can have a node on the blockchain that is allowed to invoke a smart contract, but not deploy new smart contracts. And in Hyperledger speak, a smart contract is called chain code. They're interchangeable, really. And in fact, moving forward, I'm going to use chain code and not smart contract to refer to it. So that is identity management. That's one of the features of Hyperledger Fabric. Another interest, and the reason it needs identity management is because it's because of the concept of private blockchains and the need to not be anonymous. The second feature of Hyperledger Fabric is, and it's a very interesting one, is privacy and confidentiality. It is its ability to enable multiple organizations, which all of which require private confidential transactions to exist on the same blockchain network. And it achieves this by way of having private channels or subnets that allow for transaction privacy and confidentiality. So say you have like two channels on a blockchain network, channel A and channel B. Members in channel A can transact without their transactions, member information or channel information, leading to nodes in channel B. And vice versa, members in channel B can transact with each other without members in channel A finding out what the transactions are and what the data associated with the transaction is, all the while with both channel A and channel B and the associated members being on the same network. So effectively speaking, channel A and channel B are invisible and inaccessible to each other, even though they're on the same network. So efficient processing. Like in a typical blockchain application, you can have thousands of transactions happening every second. And despite being distributed, massive amounts of transactions can build up and slow down the network. And this is the case for Fabric, is the case for Ethereum, and really any distributed application. Hyperledger Fabric tries to solve this by providing concurrency and parallelism to the network. And it achieves this by separating transaction execution from transaction ordering and commitment. So concurrency and parallelism in this context results in increased processing efficiency on each node, and also accelerates the delivery of transactions to the ordering service. And we'll talk in more detail about peer nodes and ordering service shortly. But for now, it's sufficient for us to understand that Hyperledger Fabric assigns network roles of transaction processing, ordering, and commitment by node type, and these roles are executed in parallel, thereby increasing the throughput and in the network. So finally, one of the features of Hyperledger Fabric is modular architecture. Algorithms for identity, ordering, encryption, etc. They can all be plugged into any Hyperledger Fabric network, and this allows the application to interoperate across markets, regulatory, and geographic boundaries. Because again, Hyperledger Fabric sells itself as an enterprise blockchain platform, so it needs that bit of modularity to suit itself to those specific use cases. This was all about Hyperledger Fabric's functionalities. It was if anyone wants more explanation on any of them, please raise that question towards the end of the presentation, because I do know these are difficult concepts. Next, we are going to talk about the design features of Hyperledger Fabric. Assets, chain code, ledger features, privacy through channels, security, and MSC, all consensus, all of which we kind of touched upon previously. So we will begin with assets. An asset is anything that represents tangible or intangible thing that can be exchanged over Hyperledger Fabric networks using chain code transactions or smart contract transactions. And in general blockchain speak, it is what is exchanged in a transaction from one node to another. So in the example of a Bitcoin is a asset which is being exchanged between the nodes or participants in the network. Again, on the topic of chain code, this is a software. I'm sorry, yeah, I think like, is there like some latency in how the presentation is being delivered? I feel my laptop is slower. But anyway, moving on, so chain code, this is the software that is running on the ledger, which encodes the assets and business logic for modifying these assets. Next is ledger feature. So ledger is really the sequence or temporal-resistant record of all the state transitions that are taking place in the network of Hyperledger Fabric. These state transitions, they are a result of chain code transactions of a set of assets submitted by participating parties. And because you have a private channel with private blockchain platform with channels to ensure privacy, there is one ledger per channel, and each peer maintains a copy of the ledger for each channel of which they are a member of. So you can have a certain node who's like a member of say 3 channels, and in this case, this node will maintain 3 ledgers on its machine, one for each of the 3 channels. Is that making sense to everyone? Okay. Next up is privacy through channels. And we've already talked quite a bit about channels, private channels, and privacy. I'm not going to repeat everything here. I just want to emphasize that Hyperledger Fabric uses the concept of one ledger per channel. And this channel can be shared across the entire network, or it can be limited to include only certain nodes on the network, effectively making it a private channel. And all the assets transferred across a node, across the network in the channel are encrypted and can only be decrypted by nodes that have the private key that was used to create the original ciphertext. So all in all, and this is like a huge cell of Hyperledger Fabric, it's a very secure platform and a network which can be, it supports a network which can be private. Security and membership services. So Hyperledger Fabric network is such that every participant has a unique identity, which is created using public key cryptography. And as it is true for any blockchain, not just Hyperledger Fabric, but with Hyperledger Fabric, this unique identity, which is tied to organizations, network components, and end users or client applications, along with the existence and capabilities of private channels, they help address scenarios where privacy and confidentiality are paramount concerns. So if you can have an enterprise use case where anonymity is not possible, or it's something that has to be addressed with, then you get security and membership services that you can use to tie back transactions to users who are represented using the public keys. Consensus. So yeah, like Hyperledger allows for flexible and scalable consensus algorithms. And I guess when we speak of consensus in Hyperledger Fabric, we're talking about the full circle verification of the correctness of a set of transactions that comprise a block in the network. And this includes everything from proposal and endorsement, ordering, validation, and commitment. What is interesting about the way Hyperledger Fabric achieves consensus is that it is at a transaction level, and I alluded to it earlier. This means that only the nodes that were participating in a certain transaction are part of achieving consensus. Other nodes don't need to participate. And this is very different from other blockchains like Bitcoin, which use proof of work or other incentivizing mechanisms to have nodes participate in a transaction. And Hyperledger Fabric is also very interesting in that it allows users to plug and play with the consensus algorithm that determines ordering. The default consensus algorithm is called practical Byzantine fault tolerance, and it's based on Casper and Nichols' work that you can look up. I'm not going to go into detail about that algorithm. But you can disable even like the default consensus algorithm altogether. For example, if you're deploying it in one organization only, where the actors are all part of the same organization, you don't really need consensus in that scenario, so you can just disable consensus altogether. Or you can enable it. You can use practical Byzantine fault tolerance, or you can bring in your own consensus algorithm and plug that in. So it's a very pluggable architecture in a lot of sense, like consensus, MSP, all of that is plug and play when it comes to Hyperledger Fabric, depending on what your use case and scenario is. Identity. So now I think we have the basics out of the way. We will I think now I'm going to talk in more detail about identity. I'll talk about membership and nodes, and we're going to start with identity. So identity, we're going to tackle the following questions. We're going to ask ourselves, what's an identity? What are PKIs, digital certificates, authentication and private public keys, certificate authorities, and certificate revocation list? Yeah, so like each actor in a blockchain network, be it peer nodes, orderer nodes, endorsers, whoever, they all have a unique identity which is tied to a digital certificate. And the default is an S509 digital certificate, but this can be customized in the membership service provider. And we'll talk about peer nodes, orderer nodes, and other kinds of nodes and membership service after our conversation on identity, but I don't want to sidetrack. So yes, each node or actor has an identity tied to a digital certificate, and this identity or certificate determines what permissions a user or actor in the network has. For example, can they invoke a chain code or smart contract? Can they deploy a new chain code? Access management, stuff like that. Very important to the concept of identity in Hyperledger Fabric is that it's verifiable and traceable, and this is very different from Bitcoin or other blockchains which rely on anonymity. So, like, I guess the point I'm trying to run with is that identity in Hyperledger Fabric is verifiable and traceable, and therefore must come from a trusted authority. And in Hyperledger Fabric, this trusted authority is your PKI certificate authority. PKI, for anyone who's new to this concept, is the acronym for Public Key Infrastructure. The PKI essentially is a collection of internet technologies that provide secure communications in a network. It dispenses many different kinds of verifiable identities by issuing digital certificates to parties who can then use them for authentication. And these certificates are not valid for infinity. They may expire, they may even be revoked. And this list of invalid certificates is maintained in a CA certificate revocation list. And this concept of revocation is important because if there's ever a scenario where, say, like some nodes were compromised in a hack, then you can revoke their CA certificates and add them to the certificate revocation list. Membership. So I mentioned membership service provider in the next slide. Let's talk a bit more about that. So we know from the last topic that a PKI provides verifiable identity through a chain of trust. A membership service provider determines if such a given identity is a trusted member of that blockchain network or channel. That is to say, like, which certificate authority is trusted to define members of a domain or organization on the network. This can be done either by listing the identities of the members or by identifying certificate authorities are authorized to be valid identities for the members, or through a combination of both, really. So I guess, yeah, this is like, I think, a great example. Like, I use this as an example of tying in all of the three concepts I just spoke about, identity, PKI, and MSP. So, like, you can think of identity in a blockchain network, like, say you're traveling to a country, your identity in a blockchain network is like a passport, and this passport is issued by your government, who in our jargon is the PKI, or public key infrastructure. And when you want to travel to a different country with your passport, agreements between your home country and the host country will determine if you need a visa before flying out, or if you can get a visa on arrival, things like that. And these agreements, which enforce your identity and permissions to land and enter a country, they are like the membership service provider of blockchain, of not blockchain, of Hyperledger Fabric. So now we're going to talk about nodes. This is the most basic concept of blockchain, but like now thinking back, I should have covered it first, and we'll talk about this now. So what are nodes? A node is the communication entity of the blockchain. Think of it as a domain which talks to the network. You can have multiple servers grouped into one domain, and all of that represents one. All of those servers represent one domain in the network, or one node in the network. And you can have three kinds of nodes: client node, peer node, and ordering node. A client node represents the end user. It must connect to a peer to communicate to the blockchain, and clients create and invoke transactions. They also broadcast a transaction to the ordering service. A peer node receives ordered state updates from the ordering service, and they also maintain the state and copy of the blockchain. Additionally, they can act as an endorser. So an endorser or endorsing peer, as the name suggests, endorses a transaction before it is committed to the ledger. Next is ordering node. So an ordering node is a node running the communication service, which implements a delivery guarantee such as atomic or total broadcast. So when clients connected to the channel submit the transaction, it is first sent to the ordering node, and these ordering nodes ensure that all transactions are delivered to all the peers in the same logical order. And when these ordering nodes send out these transactions to the peers, these transactions become candidates for inclusion to the blockchain or to the ledger. And you can have more than one ordering node. Together, collectively, they will form the ordering service. And this ordering service can be implemented in different ways, from a centralized service to distributed protocols that target different networks and node models. All of this is like, it depends on the architecture you come up with for your application using Fabric. So I think I covered a lot. Yeah, it's like 10:30. I covered a lot in the past half hour. We talked about blockchain and Bitcoin. We talked about Hyperledger Fabric features, architecture. I covered a lot of concepts that are fundamental to Hyperledger Fabric in a very high-level view. Next, like I want to wrap up the first half an hour by just taking a quick look at the use case, where I'll actually be playing like a video, like of how Walmart is using Hyperledger Fabric in ensuring in the supply chain of food. We'll take a quick look at that. Actually, can you guys see my screen? I have the browser open. Let me share. I'm not sure, like, oh, I can see the chat here. Never mind. Oh, I'm so, like, you can do it. Was everyone able to hear me? Because I just saw this message from Aisha that she could barely hear me. How about everyone else? Marie, Meg, question. Yeah, it's like I guess I said this was just like an issue with you. I can hear you. Okay, perfect. I said there are questions. Like I can like if there were questions on the presentation, I can answer them afterwards. But yeah, like going back to the use case I was going to show. This is the IBM website, and IBM is like really big in like they are one of the organizations behind Fabric, and they're really using it with some industry partners. So the one that I find really interesting is how Walmart is using it. So if I go to, which one would it be? Supply chain. Oh, I guess it's on supply chain. Or consumer, it might be consumer. I guess my internet is and my laptop in general is just very slow. Their food safety and traceability. I really want, yeah, this one. So this is a 3-minute video. It shows how Walmart is using blockchain. Can you guys hear like the video? Because I'm not sure. Like,
that's just a pack of mangoes. I came into my staff meeting. I put them on the table and I said, "Your trace back starts right now." And we timed how long it took them to get the information for each point of the pieces and all the way back to the farm. And I'm not going to give you the results after the pilot, but it's going to be good. When a customer shops in our stores, we know they expect great prices. We know they expect fast, clean, and friendly service. But an unspoken expectation is that they expect the products that they buy in our stores to be safe. You know, when there's a food event or a food scare, what you want to do is you want to be fast, but you want to be right. That food product is guilty until proven innocent. We at Walmart will actually pull all the ultimate goal. Blockchain will give us the ability to not only track where food came from, but how it was. Was it produced safely? Was it produced responsibly? Is it sustainably grown? How many days of shelf life are left on that product? The food system is a shared responsibility. And for blockchain and traceability and transparency to work, we need a lot of people working together. So we're excited to be working with IBM on this blockchain initiative. But it's not just Walmart and IBM. We actually have some of our suppliers participating in this pilot. We've got the universities also participating in the pilot. And so we'll make sure that all stakeholders work together for a safer and better future.
so yeah, guys, that sounds like that's one of like the best use cases I've seen of, or the most interesting to me at least. Here in Canada, or I guess in the US, about how how Hyperledger Fabric is being used in the industry with Walmart. You guys can like browse through their other use cases. I think IBM even partnered with Bombardier to use Hyperledger Fabric in something. So there are like tons of use cases, of actual use cases being used in the industry or being considered. Yeah, so I can just share this link with you guys. And you can take a look. I think it's super interesting, very useful. And I personally find it very exciting to see where we are headed with all of this traction that blockchain has received, and especially Hyperledger Fabric. So the next thing I am gonna, initially I was gonna do an actual walk through an application, deploy the network, write a client code on top of the network to interact with it. But I'm having internet issues, and so I won't be able to do that. What I will do instead is show you guys an application I already wrote that from before that, and we'll go over the smart contract or chain code that is used to make changes to the ledger, and I will also show the Node.js application on top of it. But before that, I'm going to answer Megan's question: how do you decide between using Hyperledger or Ethereum? So I think like it really boils down to what your use cases. If there is ever a need for the data that is being shared on blockchain to be private, or to not be visible to certain parties, that's when you're going to use Hyperledger Fabric. But if you want the data to be public to everyone, then it's the use case. Then you're going to use Ethereum and not a private blockchain platform like Hyperledger. And this is why like Hyperledger is like a very enterprise platform where, for example, banks are using it because they want to use some of the features that blockchain provides around immutability and the ability for the data to be secure by being more robust against hacking. But because the data is so confidential, they don't want it open to the public, and they're going to use Hyperledger Fabric as an example as a platform of choice. However, if there's a consumer application where the sellers that users have to be able to view the data, then you're going to use Ethereum. I hope that answers your question. So now, are there any more questions before I go into the coding section of it? Okay, I guess not. So I already have this application from before when I was doing something, and what I'm going to show is the chain code I wrote. Yeah, so Hyperledger is for private network only. And they actually just came out with version 1.3 of Hyperledger Fabric, where in addition to the data being invisible to actors that are not part of the network, they introduce this concept, and it's very interesting, called private data, where data can now become private even between members of the same channel. So say you have 4 members that are part of a channel, and you want only 2 members to be able to see certain transactions. You use private data to process those transactions. So like only 2 of the 3 members in the channel are now viewing the transaction and working with the transaction. So Hyperledger Fabric provides a lot of those kind of, I guess, channels and segregation of the visibility of data. Yes, now going on to the, again, I'll just show you guys like a chain code I wrote, and I don't remember where exactly I wrote it. Maybe it was in a fab car. So, sorry. Yeah, so chain code in like Hyperledger Fabric is written in Go, and so this is like a Go file that I wrote, and it's a very simple chain code. It was like for a demo for another thing, and this is used, like this chain code is used. Let me actually maximize it. The chain. Oh, can you guys see my screen? Like I'm sharing a terminal. Maybe you guys cannot see this actually. Yeah, you guys can see it. Okay. Yeah, this chain code, this was written just to demo that you can transact, or you can interact with the blockchain network through the use of two interfaces: this set function and this get function. And the way it works is when you deploy this chain code through the network, this init method is going to get called, and it will only get called the first time it's deployed to the network. Subsequent calls for subsequent deployments, for example, to upgrade the network, will not call this init method again. So any initialization you want to do, it has to happen in this method. And then this invoke function is called every time we invoke this chain code or smart contract from our client. And here it checks for what's the argument to this, what function was being called. If it's set, then it calls this set interface that that takes in these arguments and writes the key value pair to the blockchain. There's other get method I wrote, which gets a value from the ledger given its key. It's a very simple chain code that just writes and gets data from the network. There is no other logic around it. Like you could have extended the simple asset struct to more fields. For example, you could have had something like simple asset, maybe name, some type, string, stuff like that. You could have extended it that way. Type, not type. Maybe if the asset represents like some asset which is like an electronic, for example, then manufacturing date, manufacturing date, string. And so this was like, you could have extended it, but this chain code itself is what programming language can you use in Hyper. I heard. So when it comes to Hyperledger Fabric, the chain code itself is written in Go. You can write client applications on top of the network to call the chain code using Node.js, Java, and Go. Solidity is used only for Ethereum. It's a DSL that's like only for Ethereum. You don't use it for Hyperledger Fabric. So I can show you like maybe in fact, so this was the chain code. It's written in Go. Once it's deployed, you can create client applications. So like I wrote this one application called query.js, and this is written in Node.js. It queries the network which was deployed to include that chain code using Node. And here you can see like if I'm this one, I guess if I start from the top, it's using all these libraries. You need the Fabric client to talk to to Hyperledger Fabric. It's this is like just setting up the Fabric network. And here you're assigned like, I guess like this is the most interesting part where first you get like the user who is making the call, and here you have your request where you're creating the request object by specifying the chain code ID. Then the function that you're calling. Well, like this is a different one, but for the two functions we wrote, you could have said get here, and you could have passed in the argument to say maybe if something we persisted to the blockchain had a key with saying map, then you could pass in the argument, which would be the key to the data that was added to the blockchain, and you would have just run this a file, this Node.js script, and it would have queried the network for this piece of data. Does that answer your question? I mean, like I actually, like, you know, I mean, it's quite unfortunate I cannot demo it because I need to be able to talk to, I need to pull some Docker images for this to work, but my internet is really bad today. So I cannot really demo it, but you can write it. You can write applications using Node.js, which is what I have here, or Java or Go. The smart contract itself can only be written in Go.
And so not Python?
No, Python. Python is unofficially supported. Like I haven't seen, and I've never used Python to work with Hyperledger Fabric.
Okay, thank you.
Yeah. Are there any other questions? You know, like I feel really bad because I really wanted to do a technical demo. So what I will do is I will make a recording of what I was going to show, and I can share that later. I think by tomorrow or Tuesday, if that's fine with everyone.
Yeah, sure. Thank you.
Awesome. Are there any more questions? Okay, so I guess, yeah, like we still have 10 minutes, but like there are no questions. I'm just going to spend, I guess, some time tomorrow creating a video for you guys so you guys can actually see how we would have worked with, like, I would show how to deploy the network on your local machine, how to write a Node.js application or client on top of it to query and write data to it. It's not going to be a long video. Like I'd make sure it's like very short. You guys can take a look, and if there are any questions, like please shoot me a message. So I guess with that, I'm going to end the call. Thank you everyone for joining me. I love sharing knowledge about blockchain and especially Hyperledger Fabric. It's a very powerful platform. Yes. Bye.